Welcome to another GC basic demonstration. This is part 12 for the 18FxQ20 chip family. So now we're going to do some graphical LCD using I2C, I2C. I use them interchangeably, I am sorry. Anyway, let's get into it. We previously, in this series, we looked at how to discover I2C devices on the bus. So now we're going to use that bus with the GLCD attached. I am not going to go into what this chip is, etc. We're going to go straight into the nuts and bolts because I don't want to spend too long showing you this stuff. So essentially, I have got two new connections on my SCL and SDA line, and they're connected to port B5 and B6, as in the diagram on the screen in red. And I've got them pulled up. So I've got the chip, I've got some data lines, and that's for the data line to the particular called the SDA, and I've got the clock line or SCL to the SCL on the GLCD. If we look at that in the on the desk cam, here it is. It's here. And if I look at that Zen mode. I even use the same colors. Look, I always use the same color. So I've got I've got ground, 5 volts coming in. It's actually red. That looks like orange on the camera, but it's actually red. 2 resistors to these 2 data lines, and you can see, you can work out that they're the same place. And in here, I've got the VCC ground, SCL, and SDA. So these pull-ups are critical to the operation. What I'm going to do is I'm going to do a quick discovery to make sure it's working using hardware I2C, and then I'm going to do some work. And I'm going to look at some primitives, some sprites, and a voltmeter. Because we've already done the nuts and bolts of this stuff. So let's get straight into it. And we'll look at back to discovery and make sure it all works. So what I've got is a showing the devices on the bus. I could do that by looking at the terminal. We saw this earlier on. We're looking for this type of result. This is where I left it previously. It was working on the software, I2C, but now I just need to turn it over to hardware. So I'm just going to reprogram it by this time function key F4, and you can actually type in make hex and flash, and it will compile it up. Then it will move it through your programmer out to the chip. Toggle over to the terminal, and the terminal, the moment it's programmed it, a few seconds later, it will then, if I connected to it, I wasn't connected, it will show us the address. And here we go. And the hardware I2C is shown on the terminal as ports 78 and 79, so therefore we know it's there. Now we know that, we can actually load some graphical code because we know this is a GLCD. Let me come back into here. I've got the program ready to rock and roll. Here's all the sample programs listed. I'm just going to go Control F and put a little filter on there and say just filter on GCP files, and press the little down arrow there and it filters. So let's have a look. We've got a program called using SSD 1306. That's what this is. Pixels 128 by 64. That's what this was in that camera, in the camera I showed previously. And in here, I've already showed you how to set up essentially the PPS and the bus itself. And now all I'm going to do is add in this bit of code here. It says include a graphical library with the include statement. Less than or greater than means load a library called glcd.h, and it will then load in whatever library is defined in this particular constant, and it's called glc type, and there is my type. And there are lots of different types listed in the help. You go to the help and you can have a look. There's many different glcd types, about 34, 35. And the address that I'm going to be talking to is the address we got from discovery. glcd underscore I2C underscore address 078. And this library supports hardware and software, so you don't have to worry about other things. And in here, there is a program, and that program is going to put some text on the screen. It's going to write some words. It's going to draw some circles. It's pretty simple stuff. I mean, I've also in here, I've laid out how you can actually reduce the memory count uh, and using what's called a low memory mode and text mode. That's all there in there for you, so you can have a play. But if we program that and then we go out to Zen mode, if I can get there quick enough, because it does compile rather quickly, it's just erasing the part. Done. It's then just put the text up. GC Basic. It says it's more text, and then it's got boxes, circles, etc. And I hooked up in this program here, I hooked up the potentiometer so that when I rotate the potentiometer, I can then look, it's dynamically changing on the value of the potentiometer. You can just work it out. You can just see me. Oh, actually, I might be able to move the camera. Oh, that's cool. Look. As I rotate that, the LED, look, I get the little white thing here on this. Oh, look at that. Isn't that cool? Look at that. I've forgotten I've done that. Look at that. And it's just counting through, drawing some circles, boxes, lines, and things like that. It's extremely simple to draw lines in the program. You simply say lines, circles, box, draw a string, print a string. And all this is documented in the help. So all the commands, generally, the print ones are GLCD print, but historically they were called box, line, and things like that. And so historically we've kept those as being the functions. And you can see that it says a filled ellipse, and that filled ellipse is dependent upon an ADC value, which is reading the ADC. If it's greater than 127, it puts it on the screen. There we go. Isn't that fantastic? Yeah, and it's quite fast. This is not optimized code by any means, but as you could see on the camera, that's working quite nicely, counting away and doing its funky stuff, and it's updating the whole screen each time, which is great. Let's have a look at other programs that are in here that I've provided. What's this one here? That's a different parameter, is it? It's a BMP. Oh, I haven't tested that. Let's just, is that intended for this particular? Oh, I think I'll skip over that and come back to it for you. GLCD Sprites. Oh, this is cool. Same headers. This was written by a gentleman called Stan. He wrote it a few years ago. And what we're saying here is that we're saying that we're going to reprogram it, and then we're going to draw a box, and then we're going to move a sprite around the screen. And that sprite handler is documented inside of the program, and we'll have a look at that in a moment. And there's a delay, and the delay is in there is because we wouldn't be able to see it with our camera, but you can see it's bouncing away. So if we look at the source code itself, you've seen how to do an initial screen with box and prints, and then it's essentially written a little routine, and that routine draws the sprite in an X position and Y position and a sprite choice, because you've got different choices. Let's see what those choices are. Whatever those, it's actually in here, is defined different in the bottom of this program. There's a series of sprites you can choose from, 1, 2, 3, etc. 4, 5. There's many different ones you can play with. And essentially what he's doing, he's drawing that sprite in this routine. The rest of it is X or Y calculations. Let's have a look how he's doing this. He's passing it an X and Y position, an old one as an overdraw. He's actually overdrawing what was previously put there. And in here, we can see there's a lot of complex calculation, but essentially it comes down to, and I'll try and find it for you, here. He streams the data out. So he opens up what's called a transaction. That's essentially a start. He sends data by writing transactions out to this graphical device, and then he closes the port. And that's this open, write, and close is an I2C construct to enable you to stream data at high speed across the I2C bus. Very, very smart, very, very nice, very nicely done, bouncing away. I think if we change the speed, there must be some delay in here. Sprite delay is a constant, 10 milliseconds. I don't know actually, we'll just try changing the sprite choice. Like it says here, 2 seconds is the lower limit of visual perception. That's quite interesting. Reprogramming it. That's the header box we saw. Quite clearly, you can't see it. I can see it here. The camera's not picking it up at all, okay? So I'm going to set that to 3. I can see it here on the screen, but the camera is not picking it up. I've just reprogrammed it with 2 different choices there, sprite choice 2 and a sprite delay of 3. It's just erasing the part, redrawing it. And there we go. Now you can see it's moving faster. Great. Let's look at a really basic voltmeter. Again, written by Stan a while ago. Same header. Essentially what he's doing, he's reading the ADC. Let me just find the commands for you. He's reading the ADC here. He's putting that in a value, and then he's scaling that to make sure it operates correctly to 5 volts. And I'll show. Oh, let me show you operating it. It'd be the easiest way. I'm going to program it. I just pushed function key F5. We'll go out to Zen mode. Get rid of the code. There we go. Erasing the part. There we go. Great. And in here, you can see as I rotate the potentiometer, we get like a pseudo voltmeter. Look at that. Look. Isn't that great? Good old Stan. Look at that. That's fantastic. Yeah. How does it work? He's actually loaded a trigonometry library to do the heavy grunt on the maths. And that heavy grunting in the maths is done very simply by loading up the maths libraries. And he's actually using sine and cosine to draw and calculate the positions of the X and Y position for the line that he's drawing. All he's doing is drawing a line, but he needs to calculate the X and Y positions. And then he draws a line between the two. He draws a V. He then draws out, he writes out the voltage and then draws another line. And it really is that very simple. And it just does it every 20 milliseconds. But there's a library, and that library is loaded through the include line. And we'll see that if we look at the top of the program. It says here, include trigonometry to 2 places. I don't know why it's up there. It should be a bit lower, to be quite honest. It's just a bit of a strange place to put a library. I'll just put that down here so that you can see it. So it's using trigonometry, but what you're getting is a pseudo voltmeter, which is no bad thing, hey? There we go, down to 0, and that's correct. I'm pretty certain that this is a very robust piece of program, so I'm not concerned about that. So what I wanted to show you is that you've got primitives, you've seen the primitives. If you look at that again, the desk cam, you can see that you've got in here you've got circles, partial circles, numbers, strings, etc. You can get all the ADCs up there. You've got different fonts. You can do a lot of stuff even on this very, very small screen, and the same command sets work right the way across any library, but not just the I2C libraries. So what I wanted to show you was some very simple GLCDs and how it works, because the GLCD library is above the I2C library. If you can think about it as being like a little stack, that little stack is like this, and I'll show you on the screen. I'll draw it. What you've got is your user program at the top, UP. Then you've got a graphics library. You've got the GLCD library itself, and that can be any of the 34 that are out there. Then underneath that, you've got the I2C library. And underneath that, you've actually got the chip. And that's exactly how it works. So here, the I2C, you can either have hardware, which is what we're just using now. If I change it to software, it'd be no different, by the way. I choose that. I can choose one or the other. In terms of GLCD, there's 34. I think there's 34, maybe 30. We'll say 30 plus, right, just to be safe. But I'm sure it's a lot more than that. And then up in the user program, you've got lots of commands, lots of primitives, from draw a pixel through to draw a line, different fonts, etc., and different capabilities, triangles, ellipses, etc., etc. So what I wanted to show you is using a GLCD, using I2C, based upon that we have the bus working from discovery, and then once you've got it discovered, it will work. Next, SPI. Enjoy.